number 85 from section 3.4, transformations of the graphs of functions. So with this particular question, you are not provided an explicit function, but you're provided kind of just a picture of one. The original picture has a point sitting on the origin, a point at 2, -2, and then another point at -2, 2. And this is the original picture that we're going to start with. The problem that they're asking you is, how is it going to be transformed if I take that function and give you y is equal to 2 times the function f of -x? And what we need to do here is we need to identify what each of these new pieces means. So the negative here means that there will be a reflection. And this is going to happen across the y-axis. So this may actually be, this problem that is provided for you here is actually extending beyond the knowledge and the material that we covered in class. So what you were being asked to do was to take the notions that you would learn about reflections and see if you could apply them to see what would happen if you applied the negative to the input value as opposed to the output value. So when you apply the negative here, basically what you are doing is first, before you evaluate the function, you make the input value, in other words, your x, negative. Or more appropriately, not necessarily negative, but you switch the sign. That's a more accurate way of putting it. Okay, so next, we also are multiplying the function by a 2. So recall that whenever you're multiplying a function by a factor, we are changing how fast or slow it's going to grow. Now, given the fact that 2 is greater than 1, intuitively, do you think that it will make the function grow faster or slower? And what this will do is it will make you grow faster by a factor of 2. So now we're going to take this information and we're going to create the transformation. So with this one, it's a little bit more challenging than 83 or 79 from the textbook. So what I want you to note here is it's going to be easier if we start by constructing a table. Okay, we're going to start off with the basic points that we had, so -2, 2, 0, 0, and 2, -2. So note first that we are switching the signs of all of our input values. So this -2 becomes positive. 0 is kind of immune because 0 can either be positive or negative. So if you go to try to change 0 to be positive or negative, it kind of falls off. Okay, so 0 is kind of immune, and then we would make this +2 a -2. Okay, so then what we would do at this point is this 2, we want to note that we're multiplying the output, or the y value. Because if you notice first, I'm going to note this in red, first we evaluate the function. So if we're evaluating the function, we're getting our output value, then we're going to multiply it by 2. So that means that we're going to multiply all of our output values by 2. And what this is going to permit us to do is now we can generate our new coordinate points. We would have +2, 4, 0, 0. So it turns out for this particular problem, the origin is going to remain untouched. Basically, you're not going to see any change to the origin because if you notice, we're really not adding, we are not adding or subtracting any numbers to the function. And then we have -2, -4. So if we plot these points, would have something that looks like this. So if you notice, if you compare the green graphic to the one in the pink and purple, notice that we did flip the image across the y-axis, and also notice that we stretched it, or we made it grow faster, which would make it, as I believe one of your classmates had put it, it's basically pinching it closer to the y-axis. So if you compare both pictures, it does look like it's starting to hug the y-axis a little bit more, but it also looks like it's being stretched. So basically both of those descriptors are describing the same event that's happening. I hope that that was helpful. If you need any additional help or explanation, please come see me.